We are doing the F&B business, and in every F&B business, there will be menu items, which refers to the items sold to customers. Each item will have a uniquely assigned item ID, which is the primary key. They also have the item name, price, and description. The category ID is a foreign key that references the categories table, which tell the item what category they're in. There's a separate table for the categories. It's because to ensure the item will have no transitive dependency and will be in 3NF. In the category table, they'll have a category ID as the primary key and a category name. Each item will be only in one category, while each category can have 0 or many items. Each item will also require ingredients to cook, and hence why there's an ingredients entity. The ingredients has a primary key of ingredients ID for each ingredient, and there are also ingredients name, quantity, and expiry date. There's a junction table called ingredient items, which consists of a composite key made out of two foreign keys, the item ID and the ingredient ID. The reason why this table is created is so that all the tables are normalized correctly and to reduce data redundancy. Each ingredient can be in 0 or many items, while each item have to have many ingredients, as they always require many ingredients to cook. There are also staff, which is crucial in the F&B business because the staff is used to service the customers, and each staff will have their staff ID as a primary key, their name, their age, their gender, their IC number, their phone number, their email address, their birth date, their start date, and their hourly wage. Their position ID is a foreign key reference to the position table. The position table is all the position that the staff can have. And the reason why a position table is separated is because each position, to eliminate any transitive dependency on the staff and to ensure the staff table will be in 3NF. In the position, there will be position ID as a primary key, position name, and department. Each staff can have only one position, while each position can have 0 or many staff. In this system, this is a walk-in or drive-through restaurant, so customer data is not required, but there is a member system, so the member data will be collected instead. Each member will have their own uniquely assigned primary key called member ID, their username, their member points, their age, their phone number, their email, their birth date, and register date. Each member will also have access to some redeem items, and in the redeem items, there are redeem item ID as the primary key, the redeem item name, and the points required to redeem the items. Once a member wants to make a redemption, a redemption table will store all the redemptions made. In the redemption, there will be a redemption ID. It's the primary key. The member ID is a foreign key to reference the member. The redeem ID will reference the redeem item and the redemption date. The member ID is needed to keep track of which member is to make the redemption, and the redeem item is to keep track of what redeem item have been redeemed. Each member can make 0 to many redemptions, but each redemption can only be made by one member. Each redemption can only be for one redeem items, and each redeem item can be redeemed 0 to many times. There are also tables in the restaurants, which the customer can sit and order, and each table have their own primary key and a maximum packs. Once the order have been made, there will be an order table to keep track of the orders. The order will all have an order ID and a staff ID to keep track of which staff ordered the food for the customers. And the order date. The staff ID is a foreign key that references the staff. Each order will obviously have order items, and hence there will be an order items table. The order items table is made out of a composite key created by two foreign keys called the item ID and the order ID. They also have an item quantity. The reason why the order item table is created is to ensure there's no data redundancy. In the orders, they also have an order table, which consists of the order ID and the table ID as a composite key. They are also reference key, and they also have the packs. For the relationship between order and staff, is each staff will be able to make 0 or many orders, and each order can only be made by one staff. For the relationship between order and items, each order can have one or many items, and each item can be ordered 0 or many times. As for relationship between order tables and order, each order can have only one assigned to one table, and each table can have one or many orders. And that's all for the ERD.
This one is our script table, and this one is our query table. And I will go to the sub-table as it has the most data types in the script. First is the shaft ID, which is primary key, and the data types is char. As all the ID should have a fixed length to be more organized. Next is the name, and the data types is varchar, and the name length can be different, and cannot be empty. The next is the age, and the data types is numberate, and the maximum number is 3. Also, it cannot be empty, and we check the age cannot below 18. The next is the gender, and the data types is char. And we check the gender value must be M and F. M is male, F is female. This one is the IC number, and we put the data types is char, and it is unique and cannot be empty. This one is the phone number. Also, the data types is char, and it is unique and cannot be empty. Next is the email. The same is char, and it is unique and cannot be empty. And we check the email must have this symbol and the .com. This one is the address, and the data types is varchar. And the maximum words we need to put is 1000, and it is not empty. And this one is the birth date, and the data types is date and cannot be empty. Start date also the same. The data types is date and cannot be empty. Hourly age, and the data types is numberate, and it is cannot be empty. And we check the hourly age cannot above 50. This one is the position ID, and it is a foreign key and referred to the position tables. And this one I show is the table and the value. This one is ingredients table, table, redeem item, categories, position, staff, members, items, item ingredients, orders, order items, order tables, receipts, and the redemption.
My name is Tijani, and I will explain the query and demonstrate it. So first look at the first question is a query that requires an outer join. So for the outer join, I am first thinking about the query that finds a data which is not matched, since the outer join will retrieve all rows from the both table, involve the join regardless where it is a match between them. So I set the scenario to find the ingredient that is not used in any item in our store, so we no need to purchase next time. We select from the item table, and then full outer join with the item ingredient table, which is used to link the item and the ingredient, and full outer join with the ingredient table with the ingredient ID in both tables. And we can run this first. And we find out some ingredient, there's no item ID inside, which means there is no using in any item in our store. So we can set the condition using the where clause to filter out the data is item ID is null. And then we can select the item ingredient ID and the ingredient name. Then we can get the garlic and the broccoli didn't use in any item in our store. And then go to the question B, a minimum 4 table join with a group by function query. So we use the order table, order item table, staff table, position table, item table, which is 5 table, and use the group by function. So we reach the requirement. And I set the scenario to find the staff that have the highest sales to increase its salary. So first we can select from the order to find the order information and join the order item, and then join the staff table to have the staff information and the position ID, and then link to the position table to find the position name of the position ID, and then join the item to have the item price to calculate the sales. And then we use group by group the staff ID and staff name and position name, and then order by the total sale with descending order, and we fetch first row only because we want the highest sales only. So here we select the staff ID, staff name, position name, and calculate the total sales. Using the item quantity, multiply the price to calculate the sales and use the sum to calculate the total sales. And we can run. We find that Emily have the total sale. So we go to the question C. A string pattern matching and data function query. So here we use string pattern matching and the data function query here. The scenario is cash received this month is inconsistent with the cash on the receipt. So we need to find out which staff is in charge of this order. First, we select from the receipt to find the payment method of each order, and join the order table we have the order ID, and join the staff to find the staff information, and also position table to find the position name of the staff. And here we set the condition to the payment method is cash, and use the indicate to capitalize the first letter of the data in the table, just like what I typed the word cash here. And using to try to format the order date to become the month and the year, and is equal to the system date, which is today date. And we can run. Yeah, so these 3 staff is in charge of the order in this month, and we can check using this, select the order also, and then we can show the order date is December 2024, which means it's correct. And we can go to the question D, a query that having both OR and AND. So here we use AND and OR. Okay, and the scenario is find if the item seafood carbonara pasta has any expired or expiring ingredient. So first we select from the ingredient table, which have the expiry date of the ingredient, and join item ingredient to link to the item table. And we can find the item name, which is seafood carbonara pasta, and then use AND to join the expiry date of the ingredient is below with the system date, which means it's already expired. And using OR to find the expiry date of the ingredient between system date and system date plus 30, which means it will expire in 1 month. And we can run. Now you have the ingredient ID, ingredient name, quantity, and the expiry date is also January 2025. It is correct. So we go to the question E. Question E, a query that consists of at least 2 subquery. So we have the subquery 1 here and subquery 2 here. So we also reach the requirement. And the scenario is find the member which is not active in 1 year and above, then find the quantity of item that enough point to redeem and tell them so we can attract them to come to our store. So first we can find the member which is active in 1 year, which means they order in this year. So we select the member username from the order that have the order date, and join receipt which have the order ID and the member ID. And then we can link to the member table to find the member information. And then we set the condition to order date is 2024, which means they order this year. And then we can use it as subquery to set the condition with the username not in this table. So this table means there's active in 1 year, so not in means there's not active in 1 year. And then we can select the username and the member point and the phone number that used to contact them, and then select count from redeem item table and set the condition to member is higher or equal to the redeem item point required as the quantity of item that enough point to redeem, because we use the count here. And then we can order the table using the quantity with the descending order. So the highest one will be the top. And we can run. We can show all the member is not active and the quantity of item. And we go to the last question, question F. The case scenario is our is F&B business, so we need to identify the dishes that are frequently ordered together to create a combo meal. We can select from the order item, then join the order item another ordered item. So we can have 2 order item table of item 1 and item 2. And then we can set the condition to item 1 is not equal to item 2, so they can become a combo meal. And then also join the item table of the 2 items. I will show the first edition of our code is like this one. So same, the output got 2 problems inside because the caramel and the orange juice is 2 drinks. But usually combo meal is 1 drink and 1 food. So this is one problem. And the second problem is this 2 row is the same, but they just flip over. So how to prevent this problem? We can set condition using where clause to set the item 1 category name is drinks. So the item 1 will always be the drinks, and set the item 2 category name in the western rice, porridge, noodle, and vegetarian, which is the food. So item 1, item 2 will always be the food. And then we group by the item ID, item name, and the price. And here we use the we clause to set it become a temporary table, and I name it is order together to simplify our code. So I also write a main query here. We select the item 1 and item 2 with the item name and order together time and original price and combo price from the order together here just now. And set the condition to the order together time is select max order together time, which means if we select the order together time is the highest one. And we also calculate the original price plus the 2 item price and set the combo price, and we set to apply 20% discount, so we need to multiply 0.8 here, and we can run. So we show this 4 food combination is the order to get time is highest and is price. And this is our query.